We'll start off with this problem that applies Newton's second law. It's a force of friction problem. It's a specific type of problem in which we can apply Newton's second law, obviously involving friction. In this problem we have a box of mass 3 kilograms that's pulled along the ground with a force of 10 newtons. We start off with the 3 kilograms. It's pulled by the 10 newton force. It accelerates at 2 meters per second squared. So we have this value as well. The fact that it's speeding up, in this case to the right. What is the kinetic coefficient of friction between the box and the ground? So I drew a diagram of this where we have the applied force acting to the right, which will then imply that the box accelerates to the right in the same direction as the force. Okay, so the box is going to speed up. It's going to speed up due to this applied force. It's going to speed up towards the right. We also are dealing with friction. So friction is preventing it from speeding up as quickly as it would on a slippery surface if there were no friction, if the applied force were to act all by itself. So it's not simply a problem that involves an applied force, but a problem that involves both the applied force and the force of friction. So let's see what I mean by that. We start off with this equation. And the reason why I'm starting off with that equation is because the problem mentions that the box, any object that accelerates, we can apply this formula to. We can start off with it, see if it's applicable in this particular situation, just because of the mere fact that acceleration is mentioned. So in any problem where acceleration or deceleration is mentioned, where an object is speeding up or slowing down, we can start off with this formula here. In most cases, this formula will start us off in the right direction. So let's see how we can then specify the different parts of the net force. Whenever we refer to F net is equal to ma, we have to be, again, specific about what type of net force is acting. We have to take into account what forces are involved in the particular problem we're dealing with. And the net force in this formula here will be made up of those particular forces, given, again, whatever problem we're applying it to. So in this case, the net force is made up of the applied force, because that's what's dragging it along, that's what's causing it to speed up or accelerate. And it's also composed of the force of friction, because that's what's preventing it from moving as quickly as it would move if there were no friction. So we put a minus sign in front of the force of friction because the friction is preventing the box from moving as quickly as it would when there isn't any friction. So this side here is, again, the net force. The right side remains the same. It's equal to ma. Now that we've got a specific expression for this problem, again, the expression changes depending upon what problem you're working on. We can now write in the expression for each term. In other words, FA remains the same because we've got the value for that. We're told that the FA is 10 newtons, so we're going to add that in a moment. So I'll write it down simply as FA. We can write in a specific expression for force of friction. We know that for an object that moves along a level surface, the expression is mu mg. Now, in this problem, again, it depends upon what the question is, but if we refer back to what the question is, what is the kinetic coefficient of friction? In other words, what's this? What's this mu? Well, we can find the mu by simply isolating for it in the equation. So we want to, first of all, isolate for the term that contains the funny-looking u. So we want to isolate for the term that contains the mu. So how do we do that? Let's place it on the right side of the equation. So let's add it to both sides of the equation. Add it to the left. Whatever you do on the left side, you must do on the right side, so we'll add it to the right. Okay, it'll then cancel out on the left, leaving us with just that. We can now isolate for the term which contains the mu by subtracting MA from both sides. Subtract it from the right. Whatever you do on the right, you must do on the left. So again, the MA cancels out. We get on the left FA minus MA equals mu mg. I can now, again, solve for the mu. In this case, the mu is multiplied by mg, so I can divide by mg. I'll remove the mg. Whatever I do on the right, I must do on the left. So I'm going to divide the left side by mg. mg cancels out here. I'm left with the expression for mu. Okay, go back and read the problem. You should always read a problem a couple of times. Read it again. That's the expression again for mu. Go back and read the problem. The problem is that a box of mass 3 kilograms is pulled along the ground with a force of 10 newtons and that it accelerates at 2 meters per second squared. So we have all the values that we need, 3, 10, and 2. I'm going to now fill in the values for each of these. So FA is 10. The mass, we just said, again, let's go back just so we're sure. The mass is 3, acceleration is 2. And of course G is the absolute value, 9.8. Okay, so we can plug all those in. So I get 10 minus 3 times 2 divided by 3 times 9.8. So the top becomes 10 minus 6, which is 4. Divided by 3 times 9.8, which is approximately 9. It's approximately 30. Let me just get a calculator. It's 29.4. And that works out to be equal to when we round off 0.14, which is equal to what we just wrote down above, mu, coefficient of friction.